The next thing is the rationalizing factors of a given surd is not unique. Not unique means previous only we discussed that 6 root 2 is having here not only those two, just we checked those two means those two also rationalizing factors of 6 root 2. Okay, and in the same way each and every surd is having that infinite number of rationalizing factors. Okay, just one example, say here 2 root 3, 3 root 3, 4 root 3, same irrational part. So that's why we are saying that here given surd is having that infinite number of rationalizing factors. So that's why we are saying the RF of a given surd is not unique, which means that is not only having a single rationalizing factor, it has more number of rationalizing factors. Okay, so children, see here after that thing, here we have that if nth root of a is the simplest form of a surd, nth root of a is the simplest form of a surd, then its rationalizing factor is nth root of a power n minus 1. See here example, that is square root of 2. Okay, square root of 2 is there means again here its rationalizing factor is square root of 2. Or else here n minus 1, n minus 1 means what? Here n is equals to 2, so 2 minus 1 is equals to, again we are having that 2 power 1, so we are getting this one as square root of 2. Okay, so square root of 2 is the rationalizing factor of square root of 2. So here what is that form? If nth root of a is the simplest form of a surd, then its rationalizing factor should be nth root of a power n minus 1. Okay, here we have that another one, that is if the surd is in the form of mth root of a power n, if the surd is in the form of mth root of a power n, then its rationalizing factor is, then its RF is mth root of a power m minus n. So here that is mth root of a power m minus n. Okay, just see one example. Here this is cube root of 5 square. Cube root of 5 square, which means which is equals to cube root of 25. Okay, that one only we can write this one as a cube root of 5 square. Now this is in the form of mth root of a power n. Mth root of a power n. So how we can write this one as? Its rationalizing factor is mth root. So cube root of 5 power a power m is equals to 3 and n is equals to 2. Okay, which is equals to cube root of 5 power 3 minus 2 is nothing but equals to 1. So which is equals to cube root of 5. Okay, so here what is the rationalizing factor of cube root of 5 square or cube root of 25? If like this given means cube root of 25, just we have to write like this way, that is cube root of 5 square. Now this is in the form of mth root of a power n. Okay, so what is that rationalizing factor? If the surd is in the form of mth root of a power n, then its rationalizing factor should be mth root of a power m minus n. Is it clear? So here what is that rationalizing factor of cube root of 5 square? That is cube root of 5. Is it clear? So like this way we can find that rationalizing factors of any given surds. So children, just now we discussed about that. That is rationalizing factors of monomials. A single surd is taken means that is a monomial, right? Now we are going to discuss about that the rationalizing factors of binomials. Already in previous class we discussed that binomials means if that surd is consisting two terms, then we will call that surd as binomial surd. If that surd is consisting of only one term, that is a monomial surd. So here how to take that rationalizing factors of binomials. Here I am going to take that root a plus root b. So what is the rationalizing factor of root a plus root b? Just we have to change that fundamental sign. So that is rationalizing factor of root a plus root b is root a minus root b. And in the same way, vice versa, we have to take that one is root a minus root b its rationalizing factor is root a plus root b. So while we are observing these two, while we are writing that rationalizing factors of any binomial surds, just we need to change that the sign just before of a irrational part. So here what is that second irrational part, that is square root of b. That before sign is plus, so positive sign we need to change it as negative sign, and here negative sign we need to change it as positive sign. So that's why here we have to say that the rationalizing factor of root a plus root b is root a minus root b, and in the same way in vice versa we what is that root a minus root b, its rationalizing factor is root a plus root b. Okay. Now this is for square roots. If that surds is having that cube roots, then what is that rationalizing factor? Here cube root of a plus cube root of b. Then what is that rationalizing factor here? That is cube root of a square minus cube root of ab plus cube root of b square. So this is that rationalizing factor of cube root of a plus cube root of b. And in the same way, what is the rationalizing factor of cube root of a square minus cube root of ab plus cube root of b square? Its rationalizing factor is cube root of a plus cube root of b. Okay, here also vice versa we have to take. So just one of the example for that rationalizing factors of binomials. Root 2 plus root 3. Its rationalizing factor is root 2 minus root 3. Okay, and in the same way in vice versa, what is that rationalizing factor of square root of 2 minus square root of 3? Just we have to change the symbol, that is square root of 2 plus square root of 3. Okay, these two are rationalizing factors of each other. So up to here Surds topic is completed.